Number 59, letter A. By taking the slope of the curve, verify that the velocity of the jet car is 115 meters per second at time equals 20 seconds. So this is essentially for figure 2.60. So first, look at the curve, the graph, and find time equals 20. So here it is. Now from there, let's just jot a line on up. We'll dot it. And right here is the position on the graph at time equals 20. Okay, great. So now, just make this a little neater. I'll get rid of those dots. So what we want to do now is we want to find the line tangent to this point. So what does that mean? Well, the slope of the curve or the line tangent is the line that just grazes the graph at this point, but it actually doesn't cross the graph. So a tangent line would look actually something like this for this particular point. It would just barely touch the graph at that point. So just like that. That would be the tangent line. Okay. Now that looks like a fair tangent line. It doesn't look that bad. All right. Now what we're going to have to do here is we're going to have to make a couple of assumptions. So we may not land at this value of 115 meters per second exactly, but we should be close. All right. So now what I want to do is essentially this line will represent the slope at this point. Okay. It's close enough. It looks like it's off by a slight bit, but it should be reasonable. We should get around 115, somewhere around there. So now how do I calculate the slope of a line? So we use the slope formula, right? y2 minus y1 over x2 minus x1. Okay, great. So I have to find essentially 2 points on that line, right? So let's choose, this point seems easy. It looks like it's going to intersect the graph right about in the middle, right, of 5 and 10. So what would be the coordinates for this point? Remember, the x coordinates always come first. So it'd be about 7.5. And then we don't have to go up at all on the y axis, so that would be 0. Okay, so I'll call this x1, y1. And then I want to find a point somewhere over here. All right. So maybe I'll choose 30 here. This is where it looks like it's about 30. Right, so the coordinates here would be the x value would be 30. And then if I were to draw kind of a line on over to here, maybe it's about 2,500. That looks about reasonable. So it'd be 30, 2,500. And again, this would be now my x2, and this is my y2. So all we have to do is plug it in now to the slope formula. So my y2 value I mentioned was 2,500. The y1 value was 0. The x2 value was 30, and the x1 value was 7.5. So let's just do some math. So now this is 2,500 over what looks to be 22.5. And now let's do that in the calculator. So 2,500 divided by 22.5. I get 111. So that's pretty darn close. 111. This would be meters per second. Why is it meters per second? Well, what were the units of the y-axis? Right, the units of the y-axis here, okay, was position or meters. So I got an m, and m. What are the units of the denominator of the x-axis of these numbers? Well, that looked like time in seconds, right, on the graph. So seconds, seconds, seconds. Meters per second. Easy. Okay. So now that takes care of letter A. Now let's take a look at letter B. By taking the slope of the curve at any point on figure 2.61, verify that the jet's car acceleration is 5 meters per second. So again, we'll get an answer of about 5, but it might not be exactly 5. So on this curve, notice this is just a nice straight linear line. It doesn't, have any type of curve to it at all. It's nice and straight. So I don't have to do this whole tangent line thing or whatever. I can just find 2 points on this line and calculate the slope. So let's choose the initial point here. That point has an x value of 0. And it looks like it has a y value of, it's a little tough, I don't know, maybe 17? Something like that. Let's call this x1 and this one y1. Now let's go all the way out to here. Let's go out to this point. That looks like it has an x value of about 30, right? And its y value probably is going to be about 160, right? So this should be about 160. Let's call this x2 and this y2. Same thing now for letter B. Slope is equal to y2 minus y1 over x2 minus x1. So my y2 value was 160. My y1 value was 17. My x2 value was 30. And my x1 value was 0. So let's do some math. So the numerator should work out to be 143 over 30. Okay, and now the slope will be, let's plug that into the calculator, 143 over 30, and it works out to 4.77. So again, like I said, it's going to be hard to get it exact because I don't have grid lines here, so I have to estimate it, but these are reasonable. These are way close enough. So this is meters per second squared. Okay, perfect. And why is the units here meters per second squared? Well, let's go back and let's think about what are the y units in the problem? Well, the y units, if you look back at the graph, is meters per second. So this is meters per second, right? Meters per second. And this is meters per second. And then what are the x values? The x units on the graph. The x units are seconds. So seconds, seconds, seconds. Meters per second is meters per second squared. Thanks guys for tuning in. Hopefully this helped. I'll see you next time. Remember, subscribe.